Hello, third grade. This is Miss Glassy, and today I'll begin teaching you about finding the area of rectilinear figures. You'll need a pencil and several pieces of paper for today's lesson. If you do not have a pencil and paper in front of you, please pause the video and get the materials you'll need. Our target for today is, I will be able to decompose a rectilinear figure to determine the total area. We're going to review some vocabulary you'll need to know for today's lesson. Our first word is rectilinear figure. You know that today you'll be learning how to find the area of a rectilinear figure. A rectilinear figure is a polygon with only right angles. A rectilinear figure is a shape that you can break apart into rectangles. Take a look at the 6 shapes you can see on this slide. All 6 of these shapes are rectilinear figures because they have only right angles. All 6 of these shapes can be broken apart into rectangles. Take a look at the green shape. There are several ways we could decompose this shape into rectangles. Let me show you one way we could break that shape apart. One way we could break this shape apart would be by splitting it vertically, with a smaller rectangle on the left and a larger rectangle on the right. Let's look at one more example. Look at the red rectilinear figure. This shape can also be broken apart into rectangles, but you have to break it apart into more than 2 rectangles. To break this shape into rectangles, I need to split it 2 times. I could split it once vertically here and once vertically here, making 3 different rectangles. Our next word is decompose. Decompose means to break apart. When you decompose something, all of the parts together are equal to the whole. Look at this black circle. I could decompose this black circle into 2 smaller parts, like this. Now, instead of having 1 large black circle, I have 2 black half circles. The total amount of space covered by the 2 black half circles is the same. And in fact, if I push them back together, I can see that the full black circle is still there. I've just broken it apart into 2 smaller pieces. We can also decompose numbers. Look at the number 10. You can see I also have 10 red squares next to the number 10. There are many different ways we can decompose the number 10. One way I can decompose or break apart the number 10 is by splitting it into an 8 and a 2. I've decomposed my number 10 into an 8 and a 2, but the total amount hasn't changed. I still have a total of 10, and if I add 8 plus 2 back together, it equals 10. I've just decomposed my total 10, or broken it apart, into 2 smaller pieces, an 8 and a 2. Our last vocabulary word is area. Area is the total amount of space an object covers. It's the number of square units inside of a shape. If you look at the rectangle on the screen, you can see that it's covering a certain amount of space. On this example, you can actually see all of the square units inside of the shape. If I wanted to know the area or the total space this rectangle is covering, I could count each of the squares inside of the shape to find the total number of squares it's covering. If I counted carefully, I would find that there are 18 squares inside of this rectangle. That means that the total space this rectangle is covering, or the area of the rectangle, is 18 square units. Remember, we always measure area in square units. Oftentimes, when we see a shape, we cannot see the square units inside of it. If you look at this teal rectangle here, you'll see we cannot see the square units it is covering. Thankfully, when we want to find the area of a rectangle, we can multiply the length times the width to find the total area. Length times width equals the area of a rectangle. You can see that this teal rectangle is 5 feet long and 3 feet wide. 5 times 3 equals 15. So the total area or space that this rectangle is covering is 15 square feet. Remember, area is always measured in square units. Let's also review what we know about rectangles. We know that rectangles have 4 sides. We know that rectangles have 4 right angles. We also know that the opposite sides of rectangles are parallel and that the opposite sides of rectangles are the same length. So for example, the top side is opposite the bottom side, and the top and bottom sides are both the same length. The left side here is opposite the right side, so we know that the left and right sides are the same length. We're now ready to begin looking at rectilinear figures and determining the area. This shape is a rectilinear figure because it has only right angles. If I want to determine the area of this rectilinear shape, I need to break it apart or decompose it into rectangles. I know that I can multiply length times width to find the area of a rectangle. So once I have decomposed this shape into rectangles, I can find the area of each rectangle. After we've found the area of each of the smaller rectangles, we add them back together to find the total area of the shape. Take a look at this rectilinear figure. How could I decompose this rectilinear figure into 2 smaller rectangles? One way I could decompose this rectilinear figure would be to split it horizontally, like this. There are other ways we could split this rectilinear figure as well to create smaller rectangles. We're going to go ahead and solve it with the rectilinear figure split this way. Let's look at the top rectangle. We'll call that rectangle 1. I'll outline it in blue to make it easy to see. This rectangle is 3 units wide and 2 units long. So we would say that this is a 3 by 2 rectangle. And to find the area of this rectangle, we multiply 3 times 2. 3 times 2 equals 6. So the area of this smaller rectangle equals 6. Now let's look at rectangle 2. I'll outline it in green to make it easy to see. This rectangle is 5 units wide and 2 units long. So this is a 5 by 2 rectangle. 5 times 2 equals 10. So the area of this rectangle is 10. Now, to find the total area of the entire rectilinear shape, I have to add my 2 smaller parts back together. I'll add the area of rectangle 1, 6, plus the area of rectangle 2, 10, to get my total area of the entire shape. 6 plus 10 equals 16. So the area of this shape equals 16 square units. On this rectilinear figure, I can see all of the square units inside of the rectangle. So, to double check my answer, I'm going to carefully count all of the squares. Please count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 squares inside of the entire rectilinear figure. So the area of this shape is 16 square units. Our answer was correct. Let's look at another rectilinear figure. Here are 2 identical copies of the same rectilinear figure. There is more than one way to decompose this figure into 2 rectangles. What are 2 different ways that we could decompose this shape into 2 rectangles? See if you can figure out 2 different ways to decompose this rectangle. I bet that one of the ways you came up with is to split it horizontally like this, with a larger rectangle on top and a smaller rectangle on the bottom. I bet that you also thought we could split this rectilinear figure vertically, with a smaller rectangle on the left and a larger rectangle on the right. Either one of these ways of decomposing the rectilinear figure is correct because it created two smaller rectangles that we could find the area of. Now, let's actually find the area of this shape. Here's that same shape. We'll go ahead and split it horizontally with a larger rectangle on top and a smaller rectangle on the bottom to find the area of this shape. Let's call the top rectangle, rectangle 1. Rectangle 1 is 5 units wide and 3 units long, so we call it a 5 by 3. I find the area of this rectangle by multiplying the length times width. 5 times 3. 5 times 3 equals 15, so the area of this top rectangle is 15 square units. Now I need to find the area of the bottom rectangle, because to find the area of the entire figure, we add the area of rectangle 1 plus the area of rectangle 2. I'll outline rectangle 2 in green, so it's easy for you to see. Think about what size this rectangle is. How wide is it? How long is it? This rectangle is a 2 by 3 because it is 2 units wide and 3 units long. 2 times 3 equals 6. So the area of that rectangle is 6 square units. Now, third grade, I'm going to represent my mathematical thinking using a set of equations. I know that to find the total area of a rectilinear figure, I decompose it into rectangles and then I add the area of rectangle 1 plus the area of rectangle 2. Rectangle 1 was a 5 by 3 rectangle, so I'm going to write that into my equation. I show that 5 by 3, 5 times 3, is the area of one rectangle by grouping it with parentheses. Now I think about rectangle 2. Rectangle 2 was a 2 by 3 rectangle. Again, I show that the 2 by 3 rectangle is one rectangle by grouping the two numbers 2 by 3 with parentheses. I know that I need to add together the area of rectangle 1 and rectangle 2 to find the total area, so I have 5 times 3 plus 2 times 3 equals the total area. Now, 5 times 3 equals 15. The area of the first rectangle was 15 square units. 2 times 3 equals 6. The area of the second rectangle was 6 square units. I need to add 15, the area of rectangle 1, plus 6, the area of rectangle 2, to find my total area. I want to make sure that I add these numbers correctly, so I'm going to write them vertically to add them. I'm very careful to regroup any tens that I make, and I can see that 15 plus 6 equals 21. So the total area of the entire shape is 21 square units. Because I can see all of the squares inside of the shape, I'm going to double check my answer by carefully counting all of the squares inside of the shape. Please count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. There are 21 squares inside of the entire rectilinear figure. So the area of the entire rectilinear figure is 21 square units. Our answer was correct. Let's look at this same shape, but decomposed a different way. We'll find the area of this same shape, but this time we'll decompose it vertically, with a smaller rectangle on the left and a larger rectangle on the right. We'll call this first smaller rectangle, rectangle 1. Think about what size this rectangle is. How wide is it? How long is it? What is the area of this smaller rectangle? This rectangle is a 3 by 3, and the area is 9 square units. Let's look at rectangle 2. I'll outline it in green so it's easy to see. Think about what size this rectangle is. How wide is it? How long is it? What is the total area of this second rectangle? This rectangle is a 2 by 6. 2 times 6 equals 12. So the area of rectangle 2 is 12. I'm going to show my mathematical thinking using a set of equations to show that I add the area of the first rectangle plus the area of the second rectangle to find the total area. Rectangle 1 was a 3 by 3. So I'll show that grouped with parentheses. Then I need to add the area of rectangle 2. The area of rectangle 2 was a 2 by 6. So I'll show that grouped together with parentheses. I've got 3 by 3 plus 2 by 6 equals the total area. 3 times 3 equals 9. So the area of rectangle 1 was 9 square units. I'm going to add that to the area of rectangle 2. 2 times 6 equals 12. So the area of rectangle 2 was 12 square units. I'm going to add 9 plus 12 to find the total area. I'm going to add these numbers vertically to make sure that I add them correctly. Carefully regrouping any tens that I make. 9 plus 12 equals 21. So the total area of this entire figure is 21 square units. You may have realized that 21 square units is the exact same total area we found when we solved this rectilinear figure problem by decomposing it a different way. Let's go back and look. Here we decomposed the same problem horizontally, and our total area was still 21 square units. When we decomposed it vertically, we found that the area was 21 square units again. This is because the total rectilinear figure size and shape did not change. We decomposed it differently, but the total number of square units the rectilinear figure covered didn't change. We just changed how we broke it apart. It does not matter how you choose to decompose a rectilinear figure, as long as you're decomposing it into rectangles and adding the areas of all of the rectangles together. Let's take a look at another example. Here are two identical rectilinear figures. Can you think of two different ways that we could decompose this shape into rectilinear figures? Into rectangles. I'll give you a moment to think. I bet third grade that one way you thought of is that we could split it horizontally, like this, with a smaller rectangle on top and a larger rectangle on the bottom. I'll bet that you also thought we could split it vertically, with a larger rectangle on the left and a shorter, smaller rectangle on the right. We're going to go ahead and find the area of this rectilinear figure. Let's go ahead and find the area of this rectilinear figure by splitting it vertically. Now that I've decomposed this shape into two smaller rectangles, I'm ready to find the area of each rectangle. Let's call this first larger rectangle rectangle 1. I'll outline it in blue to make it easy to see. You probably noticed, third grade, that the sides of the rectangle are not labeled. So to figure out how long each side of the rectangle is, we need to count the squares. Let's now count and see how wide this rectangle is. This rectangle is 1, 2, 3, 4 squares wide. Now let's count and see how tall it is. This rectangle is 1, 2, 3, 4, 5, 6 squares long. That means that this is a 4 by 6 rectangle. I know to find the area of the rectangle, I'll multiply the length times the width. 4 times 6 equals 24. So the area of this rectangle is 24 square units. Now let's turn our attention to the second rectangle, which I'll outline in green. Let's count the sides to see how wide and long this rectangle is. Please count with me. 1, 2, 3, 4, 5. This rectangle is 5 squares wide. Now let's count and see how long it is. 1, 2, 3. This rectangle is 3 squares long. That means that it's a 5 by 3 rectangle. The area of a 5 by 3 rectangle is 15 square units. Now, third grade, we're going to represent our mathematical thinking with a set of equations to solve this problem. It is now your turn, third grade, to use your pencil and paper. You're going to write the equation along with me to practice finding the area of this rectilinear figure. You only need one pencil. I'm going to write in different colors, but you can do all of your writing with just your one pencil. Let's start by thinking about the area of rectangle 1. What was the size of that first rectangle? It was a 4 by 6. Go ahead and write that on your paper, 3rd grade. That first rectangle was a 4 by 6. Be sure to use parentheses to show that you're grouping the 4 times 6 together because it's all one rectangle. We need to add that 4 by 6 rectangle to the second rectangle, so I'll use a plus sign to show that. The area of the second rectangle, the size of the second rectangle, was a 5 by 3, so I'm going to show that by writing 5 times 3 in parentheses to show that that's all one rectangle. This is all going to equal the area. I'll use A for area. Now, 3rd grade, we need to think. What did 4 times 6 equal? What was the total area of that first rectangle? Oh, that's right. It was 24 square units. I need to add that to the area of the second rectangle. It was a 5 by 3 rectangle. So what was the area of that second rectangle? Oh, that's right. It was 15 square units. When I add those together, that will equal the total area. If at any point, 3rd grade, you need to pause the video to catch up, you're welcome to do that. Now, 3rd grade, I need to actually add 24 plus 15 to find the total area. I'm going to, somewhere on my paper, write 24 plus 15 vertically to make sure that I add it correctly. We always add more accurately when we write vertically. I can see, 3rd grade, that 24 plus 15 equals 39. 39 equals A. Now you know that area is always measured in square units. So the area of this rectilinear figure is 39 square units. Make sure, 3rd grade, that you have everything on your paper I have on mine. You need each one of these equations to fully show your mathematical thinking when finding the area of a rectilinear figure. Now that we've found that the area of this figure is 39 square units, we can double check that our answer is correct by carefully counting all of the squares inside of the rectilinear figure. Get ready to count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. The total area of this entire rectilinear figure is 39 square units. Our answer was correct. 3rd grade, let's do one more example together. Here's another rectilinear figure. How could we decompose this into 2 smaller rectangles? I'll give you a moment to think. I'll bet you thought of 2 different ways we could decompose this rectangle into this rectilinear figure into 2 smaller rectangles. We could split it vertically or horizontally. Let's split it horizontally, making a large rectangle on the top and a smaller rectangle on the bottom. We'll call this larger rectangle, rectangle 1. Quickly count the sides and figure out what size this rectangle is. How wide is it? How long is it? What is the total area? I'll give you a moment to count the sides and find the area of rectangle 1. Rectangle 1 is an 8 by 3 rectangle because it was 8 squares wide and 3 squares long. 8 times 3 equals 24. So the total area of this rectangle is 24 square units. Rectangle 2 is this smaller rectangle that I'll outline in green. Quickly count the sides of this rectangle. How wide is it? How long is it? What is the size of this rectangle? What is the total area of this rectangle? This rectangle is a 4 by 2 because it's 4 units wide and 2 units long. 4 times 2 equals 8. So the area of this rectangle is 8 square units. Now let's represent our mathematical thinking together with you writing on your paper and me writing on the screen. Rectangle 1 was what size? That's right. Rectangle 1 is an 8 by 3. I know I need to add the area of rectangle 1 plus the area of rectangle 2 to find my total area. What is the size of rectangle 2? Rectangle 2 is a 4 by 2. And when I add those together, the area of rectangle 1 plus the area of rectangle 2, it will equal the total area of the entire rectilinear figure. Make sure that you're practicing representing this mathematical thinking with me on your paper. You'll need to do this on your assignment today. Now, third grade, I can start thinking about what 8 times 3 and 4 times 2 equal, what the areas of each rectangle are. What was the area of rectangle 1? 8 times 3 equals 24, so the area of rectangle 1 was 24. I'm going to add that, to the area of rectangle 2. Rectangle 2 was a 4 by 2 rectangle, so the area of rectangle 2 was 8. I'm going to add those together to equal my total area. Now on your paper, third grade, carefully write 24 plus 8 vertically and add. I'll give you a moment to determine what 24 plus 8 equals. 24 plus 8 equals 32. So the total area of this rectangle is 32 square units. 24 plus 8 equals 32, so the area is 32 square units. Let's count all of the square units together to double check that our answer is correct. Get ready to count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. The total number of units inside of this rectilinear figure is 32. So the total area is 32 square units. Our answer was correct. Thank you for solving the area of rectilinear figures with me today, third grade. You are now ready to complete your assignment.